Well, good afternoon, everyone. My name is Frank. Before I came here, into the room, just 10 minutes ago, I was using Anthropic Claude, and I was like, can you give me good reasoning for how many downloads of Apache Spark there will be per year? What do you think? It's like 10 millions, 50 millions, 100 millions. It's hard to judge, because there's this PyPy repos, there's Maven Central. So Claude came up with I think a reasonable reasoning, and it was like 2 to 4 billion downloads per year. So this is just for, I know there's some young professionals here, some students, it's a huge number, and I think it's certainly a technology that you should focus on. And this talk today is about the point that I want to make is that you should look into data pipelines using Apache Spark, which is a rather new technology. It kind of came out with Spark 4.1. And I want to give you some background and some motivation. And also, depending on the Wi-Fi, I'll show you some demos that hopefully inspire you to try that yourself. So at the end, I want you to be able to do something like this. Give it a second, because it's loading through my phone. And this is actually the point I want to make is, you could build a small pipeline example that gives you exactly this, probably in the time of your coffee break. And honestly, it's not the animation, because believe it or not, this animation was done with Claude Code as well. So the animation is super easy to, ask an LLM, tell it, look, what do you recommend me? What is the best framework for that? That's this massive amount of data. Can you visualize it? Put it on a globe, etc. But the data, it's live data, literally from planes flying right now in the air. And I want to show you how you can do this as one example. Oops, I don't want that again. So I work for Databricks, and Databricks is a company that started 15 years ago, I think, usually in the AI space with the lakehouse concept, but then also pushing concepts like MLflow. So the original contributor of MLflow is our CTO. The original creator of Apache Spark is the same guy. And there's one or two people who created Spark structured streaming, which is the underlying technology of what I'm talking about today, like the pipelines. I'm based in Munich, Germany. Had different things in my past. I worked as a software engineer, as a data engineer, as a software architect, etc. I know you're not here because of me, but because of the topic. So just for those who don't know Spark that well, what's super cool about Spark? When I saw it the first time, I was basically reading this first line here. So if you have a folder with any amount of JSON files, and any JSON file, again, has any amount of customer data, you simply do this read.json, and you get all your data in. And then you have these logical expressions where you can say, now filter the data set of all customers for those who drive or use an Audi car or Mercedes car or whatever. And then if you don't like this Python syntax with the data frames, you can just go to SQL and say, OK, select star from customers where car make is Audi. If you do this on Databricks in a notebook, you can actually mix and match from cell to cell using SQL or using Python. And very often people ask me, Frank, what are you using? And I'm I'm so opportunistic these days. Whatever feels more, easier for a specific task, and I mix and match within a notebook, I have to confess. But then I'm not writing production code, I have to admit as well. Now, what a lot of people don't see when we show them these tiny examples is that this is spreading out to your compute cluster or to your serverless environment, and it's running in parallel. So a lot of these problems that we call embarrassingly parallel problems, where you can just split up the data and run this in parallel, they are solved extremely well and optimized by Spark. So even this small example, if it's a huge data set, it could run in parallel, and you see this by looking at these different jobs. The other thing is, what if we go from a static data set, from a CSV file, to something like Kinesis or Kafka, Pulsar? Well, the answer is the difference is not big. Instead of read format JSON, what you do is read stream format Kafka. Same thing almost, no? Same interface, makes it super easy. And then again, you work with your data frames and you work with your filters and aggregations, etc. If you take this on a higher level, on an enterprise level, people say, okay, I get it. You can read in a CSV file. That's not a big thing. I also get it. You can read in Kafka. Super nice. You can do this with one line. Admit it. But how about the enterprise-ready data pipelines where we have these often thousands of data sources if you talk to a bigger corporation? Obviously, it's not thousands of different data sources because you can break them into these categories like cloud storage, like message queues, like databases, enterprise applications. But it's all these sources where you need to get the data in. And then we're doing this whole magic, this whole data engineering because we want to feed those use cases like could be an AI application, it could be some real-time application, could be some data sharing, some dashboard at the end. So what happens in between, and this is where the data pipelines come in, is this orchestration, data ingestion, and data transformations. And it's a outlook for today, this real-time processing. So I want to talk today about what those people who kind of started with Spark Structured Streaming, Michael Armbrust is the original creator of Spark Structured Streaming, built, looking back 10 years where they said, look, we have this running for, literally tens of thousands of customers. But if we do the same thing again today, how would we do this differently? Now, I know there's many abstractions and many frameworks, but I think we should listen to those folks who did the original thing and then very self-critically say, this is how we would do it today, and that's the technology I want to present to you. So it's kind of look back. It's a simplification. First of all, why do we need to simplify it? Isn't it good enough? Why would you not just write your Spark Structured Streaming jobs and schedule them and be happy? And the other thing is, it's in the title now, declarative pipelines. What is declarative? I want to answer all these questions. The first one is about declarative. I'm going to bother you with a few code snippets now. There's more coming, just to warn you. You don't need to read every single line. Also, I'm sharing the slides. You don't need to take pictures, but you're super welcome to do so if you want. So how about declarative? If you look at I just talked about, you can read from Kafka with one single line. Well, one single line in theory, but then you need to define what's the topic, where's your server? What do you really want to read? What's the structure of such a message, And then where do you want to write it? This is all the code that you see here. So it starts with this read stream Kafka. We define the options, then you write it to somewhere. Here we pioneered Delta, but now we do a lot of Iceberg. Actually, we do both equally. You can just choose. We write it back to a Delta table or to Iceberg table. You define checkpoints. If something goes wrong, the system will just pick up and not lose any data, and you say you want to append. And then at the very end, you do this start. That means you kind of declare a plan, first of all, but all these lines of codes, nothing happens until you run the start. So looking at one single streaming data example, it is kind of declarative already. So that's kind of good start. This is declarative. It's also a good explanation about what we mean with declarative. We declare the plan first, and then we want to run it, and we get this data into our orders table from the Kafka topic. Okay, so talk about data pipelines. What's a data pipeline? Well, it's a bigger thing than this tiny example that I was showing you. It's something that produces and updates a set of data sets. Data sets look like this. Could be 2, 3, 4, 10, hundreds, thousands of different data sets. And they need to be created or updated. That means there's typically some query attached to it. It could be Python, it could be SQL. And then there's also kind of order, like a dependency, and funnily enough, especially my colleagues in marketing, they like to call this DAG, like a acyclic graph. I always challenge them and say, do you really know what a DAG is and why you call it DAG and not just workflow or just ordered execution or whatever. But it looks like this, and this is like a nice mental model of such a data pipeline. And now the question is like, isn't that good enough? Like, why would we make these declarative? And the answer is because building, creating, operating, and fixing data pipelines is incredibly hard. Not for the tiny examples that I'm using here, but I'm also showing a bigger example at the very end, but for real data pipelines that run in production. Now, it's actually surprisingly hard if you look into a few more details. I'm going to bother you with a few more code snippets. The first one is this. Again, the Kafka example. We have the orders, they come in a streaming way. We read them from a Kafka topic. Spark reads stream Kafka, all the other things, and then we read it in. Some other data, like the customers, it's coming in from, well, the world's best data technology, Excel, as a CSV file. We read it in as a CSV file. Two separate things. They never just exist in isolation. You need to join them. We want to build these fact orders. And here again, it's written in Python. You read it in, you run this join. It's here, sorry, it's here right here. And then if you look at this, and I told you, look, the single statement itself was declarative already, so where's the big problem? The thing is now you start this at 3 different points. You have 3 different things that you need to execute. And again, you would say, well, Frank, sorry, this is the last session of the day. Let's hurry up. Why don't you just put it into one file, and then you run it, you run this, you run this, you run this, then we're happy and we go home. Well, you could do that. That's probably not the most efficient thing, especially if your data pipelines get more enterprisey, more complex. Then you probably realize the first 2, they could run in parallel. Then you need to run the last one. Now, again, like, why not just, run them in parallel? How do you do that? You start up some threads, you define the multi-threading, and you run them in parallel. The thing is, again, if your pipeline is getting more enterprisey, bigger, this is getting incredibly more challenging. At some point, you need to maintain this threading code that defines the concurrency, but then I think most of the people who deal with data pipelines, they would prefer not to do that, but focus on the data transformations. And you do both. And if you fix one side, if you change one side, you also need to change the other side. So this is like possible, but probably not what we should do these days. And it goes on. What if something goes wrong? Well, what does it mean something goes wrong? Could be like a couple of different things go wrong. First off, the things like I would do if I didn't have the first coffee of the day, custom ID, and then later on you want to join this, but you write custom ID. Typically, I would not do the identifier, but just miss the underscore. Do this early morning, do this late at night because the last coffee was too long ago. Is that something that could be caught by the system, the platform, the computer, or something? It should, it should. Another error is like, how about runtime errors? How about you connect to a database, you connect to Kafka, it's not there for a split second, but it would be there half a second later. What are you doing? Well, just add some retry code. You can do that, you don't need to read that. It's right here at the top, this decorator with retries, and then you can put this with retries decorator to all these locations in your code, and that should help. Again, you need to maintain the threading code. And then there might be other errors, like, not a technical error, but maybe next morning when your pipeline was running successfully, your boss comes in and says, the thing in the middle, we need to rerun this because any department called and they said they changed something. Let's update this thing in the middle of the pipeline, this data set. Well, you can do it. You add some logic to, startup parameters where you would, where would cater for that. And then people say, okay, Frank, you make it really complicated. Why don't we just add a workflow system on top of these, on top of these snippets, something like anyone, and any system could do. But that means, well, you could do it. Probably it's an approach. But then again, you need to maintain this DAG. Again, I'm saying DAG, was just joking about the marketing colleagues who like this word, but here it's technically really a DAG. Like, we use this DAG, we maintain it in a separate system, be it Airflow, be it something else, which orchestrates then those snippets that might run in a jar file or in a notebook. But then you have, again, both, this DAG that you need to maintain, etc. And it gets on and on and on. So I don't want to make it even more complicated, but the last example is, think about this example where we have a streaming query for the orders table, and we want to join it with this static batch query, and the first one, it only runs every 15 minutes, and the second runs continuously. So you would have two streams running here and here, a streaming join with this static table, and look in code like this, and you run this, and you run this, and you run this. But then the thing is, the streams, have to run all the time. So they start up, they run. The first one is starting up, running. The second one is starting up, running. And then that one, like the second one that is to join, needs the table from the batch. And maybe that batch was never run. Maybe it's not completed. But technically, that table is just not there. It was never created. And it runs into an error because it was not the right order of execution. OK, so since the whole thing works really well for the last 10, no more, I think it's like 15 years almost with Spark and Spark streaming, with this declarative approach per data set, like why don't we make the whole data pipeline in a declarative way? And, well, build a plan and then execute the plan. Like just follow this declarative approach. And that's welcome Spark Declarative Pipelines. So that's the new thing that came out. It's actually not really new. Like it has been a product inside Databricks. We called it DLT, Delta Life Tables. And then it got open sourced. So, I mean, self-critically, I would say Databricks is not the company that is living to open source everything. But very often in this company, and I'm there now since 5 years, the question is not do we open source it, but when do we open source it? So apart from MLflow that I told you, there's Delta sharing, there's Delta tables. Now we work on Iceberg. The governance system, Unity Catalog, just became open sourced, which was honestly for me the biggest surprise because it's like everywhere within Databricks. It's tightly integrated. And if you ask me, I would have said, like, can't imagine that it's possible even to open source this. But it's open source now, and you can use it as open source. And SDP just changed the name from Delta Life Tables to SDP, but it's the same technology, and now it's an Apache Spark project, part of Apache Spark. Now, to get there, and I think this is the slide where I have to say sorry, should be less complicated. I'll explain it to you. It's two things. One is, internally, we use these flows. But for today, since this is the last session of the day, you're all looking forward to happy hour drinks, forget about the flows. The flows technically connect the source to the data set. They kind of stream the data into this data set from the source. In a Hello World example that I want to focus on first, we don't need this. We talk about streaming tables, we talk about materialized views, and then about temporary views, which are not persisted. They only exist within the pipeline. And for this example, actually, we can get along with streaming table and materialized views. So if you take anything out of this session and you want to have a mental model for the smallest possible pipeline, that actually is the data for this amazing animation that I showed you, take away streaming table, materialized view, and the whole thing is a pipeline. If you do this in open source, PySpark, for example, you also have a pipeline YAML file that describes the pipeline. Not the DAG, just the pipeline settings and parameters. OK, streaming table. Why do we have them? Well, they ingest data. They continuously update a table. It's exactly once ingestion. If you use such a streaming table with Kafka and you run it once, it will ingest all the messages for that topic. And then if you run it again an hour later, it will take the next messages. But it remembers what was read already. And that works for Kafka and all other streaming sources, even if you drop files in an S3 bucket. It just keeps the state. It's append only. So a streaming table could not change existing rows. It will always append to a table. So it's perfect for data ingestion. It is okay for data transformations if you can do them in a streaming way. Not everything can be done with streaming operators. And then we have those materialized views. It's like a pre-computed persistent table based on a query. The interesting thing, it will be cached. It could possibly be incrementally computed. This is just moving into open source. But that's one of the ideas. That means if you have a materialized view that consists of 1 billion rows, and the expression kind of adds like, I don't know, 2,000 more, only those 2,000 more would be computed and not the whole 1,000,000,000 rows. So syntax is easy, like create materialized view, and for the streaming table, it was create streaming table. And then, well, we put it together to have a pipeline. Typically, remember I told you streaming tables for ingestion. It starts with these streaming tables, streaming table, streaming table, streaming table, and then you do this join, and then at the end, very often we have the materialized view, because you want to have some aggregation. Here again, it's split into this bronze, silver, gold. Bronze is for ingestion, silver is for joins and for data cleanup, and the gold layer is the gold table that you give to your business folks, which very often represents what you need for a dashboard. And that's it, streaming tables, materialized views, you put it together in a pipeline, you run the whole thing, and it gives you the output. In Python, it kind of looks like this, and I need to say it has changed a bit. First of all, the decorator here is table, that's for streaming table, and then the name of this definition is the name of your table. Unlike you override it, you can override it, add a parameter to this table decorator, redefine the name, and then it would not be the name of this function. But normally it's just the name of the function. And what you do is you import from PySpark pipelines. Typically now the naming convention has changed as DP, not as SDP. So that's an old screenshot. I actually kept it just to tell you, if you see the SDP, it's more the name of the project, of the product, and DP for declarative pipeline is what they all finally agreed on. And now you say, okay, where's the DAG? Well, there is no DAG. The cool thing now is if you define a table raw orders here and you define a table customers here, you can just refer to this as raw orders here, and where's it customers here. So the DAG is implicit in the code. If you change the code, you don't need to update any DAG file. Then once you have this, you say Spark pipelines run, and the whole pipeline is running. And that's it, more or less. No need for a DAG object. So to repeat, you write your transformations either in SQL or in Python. You can mix and match if you want. Even the tiniest hello world example that I have for you is mixing and matching. Well, just to show you, again, as I said, sometimes I feel like one part of the pipeline is easier written in Python. Think about ingesting from Kafka. You probably prefer to write this in Python. Actually, in Databricks, we now have a SQL function that is the same. So I could technically, and I've done that many times just because I like it, ingest from a Kafka topic using SQL. It's like read underscore, I think it's read underscore Kafka. And then once you have your transformation files, you run it. If you want to start with a tiny example, you can do this Spark pipelines in it. It gives you a template, a scaffolding that you fill out, and then it's easier. You know, you got your YAML file already, you got your example files, and you just run them. You can dry run. That means no data is written. It's just checking the syntax. It's checking if the pipeline can be executed, or you just run it, and then you also create the output. All right, now it's time to see this. No, a lot of talking. When did I start? 20 past, so we have plenty of time. That's good. All right. Again, I'm connected through my phone. If anything goes wrong, I will all blame it on the Wi-Fi. And I'm not just joking. Let's see. First of all, where's my VS Code? This is VS Code, not a big surprise. I bet most people are using this more than I do. This is my pipeline. It's a transformation folder here. In the transformation folder, let me do one thing. Before I go into this code, let me go back to 1 or 2 more slides. The demo and the examples I'm showing you is actually on a web page. If you want to replicate them, I built 2 tutorials. Now, one is the open source VS Code, PySpark, Java only, nothing proprietary, nothing where you need anything from Databricks. You're super welcome to try this. It's doing, both tutorials do the same thing. They literally grab the live data from all the planes flying on the globe, and they give the IoT data from, where are they, where they're heading to, what's the altitude, what's the speed, what's the country of origin, what's their call code, and all this data. It's kind of updated every second, and it's ingested and written into streaming table and updated like and appended. So you have this trace of those planes flying across the globe. And you can run the same example, obviously, in open source, or you can go to a free account. There's a forever free account at Databricks. It's not like the free accounts we have with AWS, where you need your credit card and it expires after 1 year. Then you kind of lose your credit card and have a new one and start again. It stays free forever. There's some resource limits, obviously. That's all the marketing I'm doing. I recommend you to go and try this. Sign up with your Gmail address. You will have an account where you can play, use Spark, learn Spark, your whole life. If something new comes out in Spark, you can try it there. You get all Databricks. You have the notebooks. You have the AI. You have the governance. And not yet, but maybe you heard, we're also doing Postgres databases for OLTP now. It's in Databricks, but not in the free account. So soon, that's not an announcement. That's not an announcement. It's recorded, no. That's not an announcement. But anytime soon, you will also have an OLTP Postgres. And I think this is super amazing. Then you can do your lake flow for data engineering. You can do your Delta Iceberg, but you can also do your OLTP stuff and just play with SQL and whatever. And it's the same example. And the cool thing is it's using a data source, a PySpark custom data source. I hacked this together. It's open source. It's a PySpark. It's a module that you pip import. And then you can use this data source, which is kind of the same thing as what I told you about Kafka. It's like spark.readstream format Kafka, spark.readstream format name of this data source, which is OpenSky. So OpenSky is a non-profit organization that is kind of collecting this live airplane data, this so-called ADSB data, and is kind of offering this with a REST API. And that's what this data source is doing. So all you need to do in your streaming table is read, stream, format, OpenSky, and then you have the data. And then, you have all the data from all the planes updated every second, which is a lot. Then you want to create some materialized view. And then in the second example, I can show you this forever free account. Now you know the background, you know about this data source. And now, again, I go back to my VS Code. And now, look at this. It makes more sense. Now, this is the streaming table. Now, the really cool story here, maybe you're not as excited as I am because I put a lot of work in getting this to work. The really cool story is you need 3 lines of code, streaming table, give it a name, and then you read from this data source. And then you have your live airplane data. Now, when I built this, we have a big summit in San Francisco every summer. And you've seen the animation with the planes. I think it looks incredibly cool. The summit in San Francisco is in one of the biggest conference centers in the world. I built this tiny demo, and you've seen those animated planes. And I thought, I want to see this demo on this 80-meter screen. And we had a meeting. Our CEO was like, that's not enterprisey enough. We want to show people a finance example. So I got rejected. Don't think about this as animated planes on a map that you could get from Flight Radar on your mobile phone. Think about this data as data that kind of, connects you to any logistics problem. If you're a global company shipping stuff, you're shipping stuff, probably which plane you put that parcel in, and then you can look it up where this parcel is right now. Okay, that's the code, 3 lines of code. A little bit more because we have this semantic sugar infrastructure stuff. if you use such a data source like this OpenSky, you need to register it. It's a Spark thing. It's nothing I can change. So we import it, and then we register it. And well, that's it. So that's the Python example. That's the SQL example that is doing the materialized view. So the Python example did the streaming table, dp.table, and that's doing the materialized view. And then what we do is we go here and say Spark pipelines run or dry run. Let's do this. Oh, I didn't show you the Python, the YAML file. I'll show you in a second. The YAML file is short. It just tells the system where the transformations are, which is for me this transformations folder. So this is running. Not doing well with the zooming. And now you see it's kind of detecting what it needs to do. So it says like you defined an ingest flight table, you defined flight stats, and this is planning, starting, running. This is all the, when I told about the problem, this is how the platform solves the problem. It looks at the code, it figures out what to do first, it figures out what to do in parallel, it figures out to do the right thing, it executes the whole pipeline. Now I run it once, you say, hey Frank, you told me it's like this live data streaming in. You can run this pipeline in continuous mode, and then you have the data coming in all the time, and the table will be updated, appended all the time. Now the thing is, where does the data go? And the answer is it goes into this Spark warehouse. It's a Parquet file. It looks like this. You've seen Parquet files. It's a bit unsatisfying, I think. When I did this the first time, I was like, okay, if I show this to people, now we end up with a Parquet file. I promised them, the animated flight data. The thing is, you can go to PySpark and read this Parquet file as a table. I'm doing it in this show results command. I'll show you how this show results command looks like. Let's look at this. Okay, we need to zoom in. Guys, it's 14:54 on my watch, and this is a plane from 14:53 in 10 seconds. So this is like 40 seconds ago, coming from the US with this call sign. With this, it's a technical call sign. This speed, this altitude, this vertical climb or descent rate. This is super cool. 3 lines of SDP. You get all this live logistics data. I think this is amazing, and that's what ST or SDP is doing. I show you. Where is it? I don't see it anymore. Here it is. 2 things. This show results, it's basically doing Spark, read table, ingest flights. And then this is huge. This is like 16 different columns. So it looks ugly when I display it on the screen. This is why I only select a few. There's many more. And then I can read the table for materialized view. I can read the table for streaming table. And that's it, basically. And I did not show you the YAML file. It's nothing. Its libraries include all these files under transformations. In transformations, what I have is a SQL and a Python file. SQL and Python just because I want to show off we can do both. We can mix and match however you want to do that. And that's the big story for open source part. You can do it now. One question these days is obviously, I could have done this from scratch because, I told you we have this tutorial, how to get started with SDP. It's this animation. Actually, what I did is use exactly such a table, and then I went to Cloud Code and said, what's the best framework to animate this on a globe? And then it was doing this in a couple of minutes. So the animation is not the cool thing. It's the data. It's always the data. Okay. Now, why am I telling you you can do this in your coffee break? The answer is because you have this tutorial. You go here, PySpark local tutorial. You click here. It takes you to the Git repo, and then this is the structure. You get the pipeline definition. You get the SDP file, Spark, read stream, OpenSky, which gets you all the live plane data. You can copy it from here, and that's it. If you try this with Cloud Code, and I did, It works okay-ish. For okay-ish, you have to know I'm working in a US team where okay means it's working. I think Cloud Code could do better. And the main problem is if you start with your vanilla laptop, like my macOS laptop, without any environment, you have to get the environment right. And I put this here on the local installation. So you need the right Java version. You need PySpark in the right version. All this has to be installed and working. So if you just say, Cloud Code, give me a SDP example, Apache SDP, say Apache SDP, because there's so many SDP. There's like 30 different meanings of SDP, and Apache SDP is not even in the top 2%. I just did the research. So there's a socialist party, there's all these spec-driven development. It's like crazy. I don't know like why we picked that name. So always say Apache SDP, and then it often struggles with the environment. Point it to this code repo if you want, like doing this like one-shot approach with the LLM. It gets much easier. I think it's also learning. Yeah, so that's one side I wanted to show you. Then, how much time I have left? 22, what is it, 5 past? I need to stop? I think so. Yeah, 45. 3 o'clock. Okay. Okay, I show you a few more amazing things, and I'll be quick. I'll be quick if I find my screens. Yes. Wait. I had one open, but I think this is it. Okay, this is the free account you can get at Databricks. I have a link in the slides. I'm going to share the slides. If you need it like before that, just ping me. I can share this anytime. Cool thing is it does a lot of more things. It kind of gives you a web UI. You see the visualization of this graph. You see here, this is ingest flights, streaming table, materialized view. You can click on this, and then you also see the data. I think this just needs to spin up. Let's see, columns. I'll show you this in a second. The other thing is if you click on Edit Pipeline, you get to this pipeline UI editor, which is all graphics. You see it's basically the same thing. It's exactly the same code that is running. Here I have my transformation table, but here I can do all the magic. I can say, look, remember we had this I can create a new folder. Like, remember I had this bronze, silver, gold, so I could create a silver folder and then say, this is my silver folder. This thing should go in the silver folder. I just move it. So you have all this functionality, like the file browser here. You can create new streaming tables, materialized views based on this, based on existing ones. The super cool thing is Genie. Genie is kind of the AI that surprisingly does everything I showed you just automatically. So you could go and say, new ETL pipeline. And let me show you one thing. The Unity catalog for governance is basically this catalog of tables. There are samples, and one of these samples is this bakehouse data set where we kind of model the global bakery. And there is like, let's say, transactions, there is customers. And here, where I want to build this new pipeline, I go to Genie code. Actually, this was running already, so let me new chat. And now here, I say, not sure if this is working. Hello? Oh, it says nope. Sorry, this is, maybe I should type. Create a Spark declarative pipeline that ingests from the bakehouse data set and joins the, what was it, transactions and the customer table. So this is not part of the UI, this is part of my text-to-speech on my Mac. This is where I said I should type, okay? Create a Spark Declarative Pipeline that ingests from big house data set, joins the, what was it? Okay, I said this. Transactions in customer table. Click on go. This will take a while, but it figures out everything. Actually, I didn't give it the right table name. Remember, it was sales underscore transactions. It was sales underscore customer. It will say, look, I find the big house data set. The table name is wrong. I'm guessing this is the right table name. And then it does the SD, it does the MV, it does everything. So I recommend to try this. It's asking for permissions. This will take a couple of minutes, so I'm not waiting for this until it finishes. But it does a surprisingly good job. I've seen the rules and the skills behind this. You can extend it with your own skills. You can extend it with an MCP server. And I've seen the skills, they're also public. There's a repo for that. We don't talk about it that much yet, but we will. And it looks amazing. You know, this is all the data engineering knowledge from all the cool people we have at Databricks in one file, and then the system runs it and applies it, and kind of, sometimes it gets stuff wrong, but it's surprisingly good. Like when I saw this the first time running, I was like, oh my God, this is impacting a lot of people, you know. Like this is doing all the mechanics, all the scaffolding, all the templating where we spend so much time for. And you see, it goes samples, bakehouse. Now it also already knows it's sales transactions. It's not transactions, what I said. It looks into the table and then it starts, you know, building up everything. It automatically does this bronze, silver, gold layer. Never told it. It's also default. So it will create a bronze, silver, gold folder here and then, you know, do the right transformations. This also extends to dashboards, like our internal joke. This is recorded now. Anyway, come on, it's the last session of the day. So our internal joke is always, like the command for dashboards is always create a meaningful dashboard. I don't know why. One of my colleagues started with meaningful dashboard, and like, why are you telling the AI system it should create a meaningful dashboard? What's a non-meaningful dashboard? But now we always do this, and now create a meaningful dashboard, and it does it beautifully. There's one more thing I want to show you, and again, it's hidden, it's here. Hopefully you're super amazed because of this live airplane data. Maybe some of you say, okay, now Frank flew all the way from Munich to Athens, and then basically what he showed us was this 3 lines where he was so excited about. But how does this translate to a real use case? Now that he even admitted, you know, last time at Summit, this demo was not shown on the 80-meter screen. And I was like, guys, this is the logistics problem. Why don't you see it? Why are you just seeing those animated planes on a map? I tell you what happened. The same demo that I showed to you, of course, all our internal solution architects have seen it. And 3 weeks ago, one of them contacted me and said, hey, Frank, I took your thing, but I just built the real application. I mean, what do you mean the real application? It's working. He said, no. I built something that we took to, now I need to paraphrase, to Europeans' biggest air traffic control that we took to, there's only one European defense agency, and that we took to two of the biggest airports that we have in Europe. And like, what? And you're like, yeah, look at this. This is what we built. So they took the same idea, ingesting from a streaming table, and then, you know, just making this, you know, more enterprisey. This is Schiphol Airport. It's like this zone section. And what they do, there's one more component in it. There's a real-time component. What you can do in Spark now, and this is why I told you you should focus on the broader ecosystem of Spark, there's something called real-time mode, where the latencies go down from, you know, what we have typically with the micro batches, couple of seconds, 5 seconds, 10 seconds, maybe 15 seconds, depending on many things, but it seemed to be this inherent, you know, lower bound. Now you can switch it to real-time mode, and then you get down to double-digit milliseconds in latencies. So they built this. This is ingesting the same way as I told you. It's using Spark structured streaming, not SDP yet. RTM is still coming to SDP. Stay tuned. Again, that's not an announcement. They're using the lower level Spark structured streaming. The thing is, all these events, all these, you know, zone congestions, that's not done on the database. That's not done in the UI. That's done in the Spark stream, you know, where you define basically what you would do with Apache Flink, but now you can stay within your Spark ecosystem. So that's RTM with Spark streaming, kind of same, principle, and all of a sudden, they show it to Schiphol Airport and to London Heathrow and to NATO, and like, guys, wow. And they're like, yeah, no, we saw your demo, we liked it, but we just thought we built the real thing. So this is how it connects, This is what I wanted to show you. With this, I want to finish here. You've been a super audience. Last session of the day, I didn't expect that many people. Thank you so much. May I take a picture? Thank you. To find my phone. Oh, here's my phone. We need it for the Wi-Fi. All right. Thank you. You want to do a funny one with thumbs up? Thank you. Cool. All right.